Okay, so hopefully you guys have had a chance to try the problem that I asked you guys to try. I know it seems a little confusing to throw in these logarithms and things here and there, especially since we haven't seen logarithms probably since your Math 3 class. But hopefully you guys have had a chance to give this a try and see what you think. So let's go ahead and see if you got the same thing I did. As seniors, you're all probably excited for your graduation parties. I know that there's some juniors in here too, so just imagine that it's your senior year. You will most likely get money from your friends to start off college with. You are smart. Yes, you are. So you decide to put the money into a savings account that earns interest so that you can save money throughout your life. Let's say you will receive $500 at your graduation party and you find a bank that has a savings account that earns 4% interest compounded annually. Here is a chart that will show how much money you will have at the end of every 10 years. You leave the money in the account. So basically, we're going to leave the $500 in the account. We're not going to touch it. We're not going to take out money. We're not going to put in money. And every 10 years, we're going to see how much is in the account. Okay? So I'm going to go to my calculator. I've actually already typed in all the information. In fact, ignore that. Okay? So here is the explanatory, and here is the response variable. So what I'm going to do is look at the scatter plot. So we want to do the scatter plot of list 1, list 2, list 1, list 2, zoom 9, okay? And what do you think of that scatter plot? To us, the very first couple times we look at it would probably look pretty straight, but do you see the curved pattern to it? In fact, if we quick look at a residual plot, we would see that curved pattern even more. So I'm going to do a residual plot real quick. I'm going to run the least squares regression option, linreg, on these two. Remember, when you run this, it stores the residuals for you. So I'm going to put those residuals back into the list. They're stored in list. So there's my residuals. Okay, these are all the residuals from list 1, list 2. And let's quick look at your explanatories against your residuals, which are in list 3. So there's a residual plot, and as you can see, it is a definite curved pattern. So the original scatter plot is definitely not linear. It's got a definite curve to it, and we can go back one more time to look at it by just switching it back to list 1, list 2, which is the explanatory and the response. I hope I'm not going too fast through those calculator options. But anyways, that's the original graph. So let's go ahead and draw a picture of that. So it says draw the scatter plot. So we've got dots that look like this, definitely curving upwards. And then I'm going to go ahead and even label each axis. This is the years, which I know I've put in list 1, and this is the amount, which we have put into list 2. I like to kind of keep track of my lists just to know what I'm doing with each of these things, okay? So, if you can see, it says, using an exponential model, find the line of best fit. So what we want to do is we want to write the equation of a better fitting line. Well, remember, we can see that it's curved. It definitely looks like it's an exponential equation, which is the one that shoots way up, or as it comes down, it evens out and gets closer and closer to the x-axis. Well, to undo an exponential, we want to use a logarithm. So I don't know if you used a natural log or a logarithm. It shouldn't matter which one. They should both straighten it out. I'm going to go ahead and use natural log. I'm going to natural log each of the response variables. If you did the log, your answer will look a little bit different, but I'll go ahead and give you the log answer here shortly too. So remember, all you got to do is go to your calculator, go to your list, and I'm going to delete out my residuals. I don't need those anymore. But I am going to turn list 3 into the natural log of list 2. So again, we're taking the natural log of all of the response variables. So that's the natural log. So these are still response variables. It's just that these are the natural log of the response. So let's go ahead and graph the explanatories against the natural log of the response. And let's see what the graph looks like now. List 1, list 3. straight that is. It was curved, and we made it super straight. So I would say we definitely achieved linearity, making it a straight line. So let's go ahead and draw that picture real quick. Draw the new picture here. So it's a very, very straight line, which is good because now that it's a straight line, we can use the least squares regression line to predict. So remember that we have years down on this side, which is in list 1, but then on this side, we have the natural log of the amount, which now is in list 3. Oops. That's now in list 3. So to find the equation of the fit, now that we've got a nice straight line, we can use linear regression. So I'm going to go back to the calculator, and I'm going to calculate the linear regression. We're going to calculate that with option 8, linear regression, a plus bx, but list 1, list 3, because list 3 is the one with the straight line. So when we run that, you can see this is the y-intercept, and this is the slope. In fact, look at how good our correlation is. It's practically 1, 0.99999. That is really, really straight. So let's go over to the notes and let's write that down. Now, remember, we're used to writing it as y hat equals the y-intercept 6.21 plus a slope of 0.039x. But it's not just y hat, it's not just the responses. Remember, we took the natural log of the responses. So all you got to do is stick the natural log in front of the y hat, and there's your equation. If you did logarithm, you'd have a slightly different answer. So if you did logarithm, your answer would have been log of y hat instead of natural log, and your values would have been a little bit different in the calculator. Your y-intercept would have been 2.699 plus 0.07 or 0.017 times x. So it depends on if you did natural log or the regular log. So those are the two answers depending on what you did. I'm going to go ahead and keep going with the natural log. So using the line that you came up with, whether it was natural log or logarithm, we are going to calculate a residual for 40 years. Well, remember, to do a residual, we need to do actual minus predicted. So we have the actual, we got to find the predicted amount. So where I'm going to use the line, natural log of y hat equals 6.21 plus 0.039. And since I want to calculate it for 40 years, I'm going to plug in 40. So I've done a little bit of this work already. So it's 6.21 plus 1.56. If we add those together, we get 7.77. And then this is just the part that you got to remember from Math 3. The base of a natural log is an e. So the way you kind of do it is I loop it around and I say this y hat is equal to e to the 7.77 power. This just becomes the exponent. So when you go back and look at your calculator to do e, remember e is above the natural log. So you go second e to the 7.77. So there is your predicted amount. That's the predicted amount we are going to have in our account after 40 years using the line. So my predicted amount is $2,368.47. And if you did logarithm, you're going to get log of y hat equals whatever the number is. I didn't calculate it out. But whatever that number is, you just take 10 to this power equals y hat. So y hat equals 10 to the whatever number you got there. And you should get the exact same value for your predicted amount, even though this number would look a little bit different. So no matter what, if you use natural log or regular log, you should get this amount for a predicted. Well, remember, to find a residual, we have to do actual minus predicted. Remember, I always say that we're in an AP class, not AB. We're in an AP class. So the actual amount we're going to look up at our chart. After 40 years, it says we're going to have $2,400 in our account. That's the actual amount, $2,400. We subtract the predicted amount. Well, the predicted amount is what we got here, the $2,368.47. So this is going to tell us what the residual is. So 2,400 minus $2,368.47 is $31.53. So our least squares regression line will underpredict by $31.53. Because remember, if it's a positive, it underpredicts. If it's negative, it overpredicts. So that's how you calculate a residual. You got to come up with the regression line, so make sure you find the straightest line you can. And then once you have the straightest line you can, you just calculate the linear regression in your calculator. And if you took the natural log of y in order to get that, you stick the natural log in front of y. If you took log of the y to get it straight, you stick the log in front of it, and then you just have to solve it accordingly. All right, so hope you guys are getting that okay. Hope that the calculator used wasn't too fast, but just go back and slow it down if you have to. Good luck with achieving linearity. Again, no homework tonight, just do the reading. You'll get to practice some more of this tomorrow.